Hi doctor, we are from group 7 and our topic is how to improve the design of heat exchanger in our daily life. So we picked shell and tube solar heat exchanger as our subject. Shell and tube solar heat exchanger is designed to heat pools of any size from small backyard pools to large municipal and resort or hotel pools. Although it is commonly used, there are a few flaws in the design that can reduce the heat transfer in the system. So how to improve shell and tube solar heat exchanger? Of course, by increasing the efficiency of shell and tube heat exchanger inside the solar heat exchanger. As you can see in the diagram given, shell and tube heat exchanger consists of baffles, tube bundle, shell, connections, tube sheet, gaskets, mounting, and heat. A shell and tube heat exchanger is a class of heat exchanger design. It is the most common type of heat exchanger in daily life and is suited for higher pressure and higher temperature application. As its name implies, this type of heat exchanger consists of a shell, a large pressure vessel with a bundle of tubes inside it, as you can see in the diagram before. One fluid runs through the tubes and another fluid flows over the tubes, which is through the shell, to transfer heat between the fluids.
A shell and tube heat exchanger consists of a bundle of tubes placed inside a larger tube, which is called the shell. The tube fluid, usually the process fluid, flows through the tubes in one direction. The shell fluid, usually the utility fluid, flows through the shell and around all of the tubes in the opposite direction. This is called a counter-current design. The shell contains baffles to support the tubes and repeatedly redirect the shell fluid across the tube bundle.
There are a few ways to improve the solar heat exchanger. One, we change the type of baffle in the shell and tube exchanger. Second, addition of fins. Third, tube insertion. Fourth, change the materials used. And fifth, change the type of heat exchanger.
The first way to improve the shell and tube heat exchangers by using the helical baffles because it can increase the heat transfer rates. Second, it can increase the pressure drop ratio, reduce shell side fouling, and prevention of flow-induced vibration. Lastly, it also reduces the maintenance. Secondly, we can increase the number of fins on the shell and tube heat exchanger because it increases the Flemm coefficient with added turbulence and increase the heat transfer surface area. Thirdly, we can insert the tube inside the shell and tube heat exchanger because it promotes turbulence and increase the heat transfer coefficient. Besides that, it also increases the pressure drops.
Next, for the material used, we are using titanium. The following are the benefits of titanium. Number 1, provide an extended service life compared to other materials of construction due to its durability. Number 2, eliminate expensive downtime due to equipment failure. Number 3, provide superior corrosion resistance. Number 4, deliver high heat transfer efficiency. Number 5, accommodate high steam pressure to reduce required surface area. And lastly, to eliminate breakage during handling, installation, and operation due to fully welded metal construction. Finally, for the type of heat exchanger, we have chosen to use brazed plate solar heat exchanger. This is because they have high efficiency and transfer ratings to minimize heat loss during the exchanger process. It also promotes high turbulence flow, and it maximizes heat transfer. And importantly, it is usable in all types of heat systems. Alright, so that's all from us. Hope you enjoyed the video. So, thank you! We are Titan!